Welcome back to Applied Mathematics. In this video, I want to talk about rational exponents. A rational exponent is exactly what the name suggests. It is an exponent that is a fractional power. The definition of a rational exponent is actually fairly straightforward. Rational exponents are roots. So x to the 1/2 power is equal to the square root of x. And if you stop and think about it, that makes sense. Because the square root of x squared is, well, x, or the negative of x, but yeah, roughly speaking, x. And if we tried to think about that as an exponent, well, then that would be x squared to the 1/2 power. And using the product rule, that's x to the 2/2, which is x to the first, or just x. So that idea of a radical as a fractional exponent seems to make some sense. In general, if I have x to the m over n power, we're going to define that as the nth root of x to the m. But in this video, I'm not going to worry too much about that. Other than being able to evaluate something like 8 to the 1/3 as the cube root of 8, and if you happen to know offhand that that's 2, then you're in great shape. If you don't, I do want to point out that most calculators have a generic root button. On my TI-36, it's right here above the generic exponent key. So I can type in 3 and then second exponent 8, and it will give me 2. Or I could have written that as a fractional exponent. 8 raised to the 1 divided by 3 power also gives me 2. Unless we have a perfect power and we can reduce things exactly, we're not going to worry about that. Right? For this lesson, if I had something like 7 to the 1/3 power, I would leave it as 7 to the 1/3 power and not do anything else. Doing something else will come a little bit later. But the real thing that I want to focus on is things like expressions, x to the 1/2 over x to the 1/3. Just because the exponents are fractions doesn't mean the rules of working with exponents have changed at all. This is x to the 1/2 minus 1/3 power, and 1/2 minus 1/3 is not 1/3, it is 1/6. Right, something a little bit uglier, x to the 1/2 over x to the 1/4, x to the negative 3/5. Same rules still apply. If you want to do this in a couple of steps, the rule for negative exponents, moving things between the numerator and denominator, still works. This is the same thing as x to the 1/2 times x to the 3/5 divided by x to the 1/4. And then from there you can continue. Right, 1/2 plus 3/5 is, what is that, 11 over 10? And then 11 over 10 minus 1/4, that's what, 22 over 20 minus 5 over 20, which is 17 over 20. All right, so fractional arithmetic, certainly the rule for the day. And once again, if you want to let your calculator do a lot of the work for you, that is perfectly fine. Right, my calculator is happy to work in fractions, and I can do 1/2 minus 1/4 minus negative 3/5, all in one go, simplifying things without having to think about it any further at all. So however seems the most useful to you. The hardest thing about working with fractional exponents is honestly convincing yourself that you know how to work with fractional exponents. The properties of exponents are the same. The properties of fractions are the same as things that you've been working with for your entire mathematical career. So there's nothing new, there's nothing crazy going on, and allowing yourself to be comfortable with the fact that there is nothing new is the hardest part. A little bit of a simpler example, but the same sort of an idea we just had in that last one. If I have something like negative 1 over x to the negative 3/5, the only thing I can do here is I can deal with the fact that I have a negative exponent. A negative exponent says move things between the numerator and denominator. And when you do that moving of things, it will change it to a positive exponent. That's it. That's all there is to it. And of course, if I have x to the negative 1/2, that's the same thing as 1 over x to the positive 1/2. Nothing crazy happening there. And if I have powers to powers, right, x to the 2/3 raised to the 15 over 16, right, there's some ugliness for us. I can't imagine where this would actually come up in practice, but simpler examples certainly could. Right? Power to a power rule, you multiply the exponents. This is 2/3 times 15 over 16, which is going to be 5 over 8. And then one last example. X plus x to the negative 1, the whole thing raised to the 2/3 power. This is the important case of realizing that there's nothing you can do. You have addition inside the parentheses. Exponents and addition do not behave nicely together. Until I know something about the value of x, there's actually nowhere I can go with this, and it's already as simplified as possible. All right, so a relatively short video here because, again, there is nothing new. There's nothing that we're doing that is crazy and different and not something that you've been able to deal with in a previous course. It's just a matter of putting it all together and convincing yourself that it is exactly as it seems and not trying to make a mountain out of a molehill. All right, with that, I think I'm going to wrap up this video. As always, thank you for joining me. I'll see you next time.